Gas law notes for worksheet 1. Gases and their laws. Pressure is a force applied over an area. Pressure equals force divided by area. You can measure pressure with barometers, gauges, manometers. Units of pressure, millimeters of mercury, inches of mercury, PSIs, which is pounds per square inch, atmospheres, pascals, which is short, PA is short for pascals, or torrs, which is short for torricelli. 1 atmosphere is the pressure you would experience at sea level, and an atmosphere is equal to all of these units: 760 millimeters of mercury, 29.92 inches of mercury, 1 torricelli, 14.68 psi, 1.013 times 10 to the 5th pascals. Make sure you know how to do pressure conversions. You will be given these unit conversions on a test, but make sure you know how to do the conversions. So let's try this. This is practice number 1A from worksheet 1. It says change 6.2 atmospheres into millimeters of mercury. So we'll start with 6.20 atmospheres. And we will go times a line. And we're going to put atmospheres on the bottom because we want to cross cancel those. And we'll put millimeters of mercury on the top since we know a direct relationship between those two. In fact, 1 atmosphere is 760 millimeters of mercury. We'll do 6.20 times 760. We get to cross out our ATMs. And we end up with 4,710 millimeters of mercury. And we have 3 sig figs because we started with 3 sig figs. This does not count because it's a conversion factor, so we have 3 sig figs: the 4, the 7, the 1. That 0 doesn't count. It would only count if you put a line over it or a dot at the end of it. That would be a decimal. Now let's move along. Boyle's law is concerned with pressure and volume. Pressure and volume are inversely related. As one increases, the other decreases, and vice versa. And there's the formula. P1V1 is P2V2. And the type of graph that represents Boyle's law is an inverse graph, which has a negative slope. And this is a great graphic, but I'm unable to use my video system and capture this, so you might want to look at the notes online. And here's an inverse graph of volume versus pressure. So what would happen to the pressure if the volume were cut in half? So if you decrease the volume by half, that would mean the pressure is twice as much. And what would happen to the volume if the pressure were decreased by 1/3? So if you decrease the pressure, you are going to increase the volume threefold. We're going to do Boyle's law practice number 2A from worksheet 1. A sample of oxygen gas has a volume of 2 liters at 27 degrees Celsius and a pressure of 2 atmospheres. What is the volume in liters if a new pressure equals 3.13 atmospheres? What I like to do with these problems is to write out what I know. That is, I don't know if that's a word. So the first volume we see is 2.00 liters. We're going to call that volume 1. Make sure you put your unit on there. And then we're even given a temperature, which we won't actually use, but I'll write it down because we know that. It just isn't going to help us. And we have a pressure 1, which is 2 atmospheres. And we also have we're trying to find the second volume. That's what we're trying to find. And we're trying to find it in the unit of liters. And the second pressure is 3.13 atmospheres. So we're going to bust out the equation. P1V1 equals P2V2. And we're going to be very smart college students and isolate V1, impress your teacher, and do P2V2 over P1. So we're going to do our algebra first because we tend to make less mistakes mathematically with that, and then plug in our numbers. Ooh, I did not leave a lot of space. We're going to plug in 2 atmospheres times the volume, which is 2 liters. Get all your sig figs in there. And on the bottom is going to be P1, which is 3.13 atmospheres. Actually, that's P2. I take that back. Did I get that backwards? We're trying to find V2. Oh my, MSA. We're actually trying to find V2, which is P1 V1 over P2. Sorry about that. So we're going to do the math with those numbers, and we're going to get 1.28 liters. And again, we have 3 sig figs because all these digits in here have 3 sig figs. Now we're going to look at volume and temperature, which is Charles' law. Jacques-Alexandre César Charles was a French scientist, a mathematician, inventor, and a balloonist. In August of 1783, he and the Robert brothers launched the first unmanned hydrogen balloon. And in December of 1783, Charles and Nicolas Louis Robert, my French is very good, ascended to 1,800 feet in a hydrogen balloon. I'm so glad that they didn't light a match. Charles' law is concerned with volume and temperature. So the volume and temperature of a gas are directly proportional. If the temperature increases, so does the volume, and vice versa. It's V1 T2 equals V2 T1. So what type of graph represents Charles' law? A positive sloped graph represents Charles' law. And here are some graphs for different elements or compounds. So collisions in heat. Think of collisions of molecules as increases or decreases in temperature. For example, a hot air balloon. The air is heated, the molecules move faster, therefore they have more collisions with their container, and thus the container expands. As the molecules move faster, there is greater distance between them, which means it is less dense, and hot air rises because it is less dense. Kelvin. Any calculations involving temperature must use the Kelvin scale. He is from Belfast, or was from Belfast. He worked on the transatlantic telegraph, and if we want to convert to Kelvin, we take degrees Celsius and add 273. If you want to go back to Celsius, you take the Kelvin temperature you have and subtract 273. So we're going to do Charles' Law practice number 4A from worksheet number 1. And we're going to write down what we know again. And we would want a pen to do that. That would be very handy. Here we go, with what we know. Maybe I'll spell it correctly this time. Good job, Miss A. So nice. So we're on 4A. What do we know? We know volume 1 is 5 liters, 5.00 liters. We know that temperature 1 is 35 degrees Celsius. Get your equal sign in there. But we can't leave it in degrees Celsius. You have to change it to Kelvin. So you'll add 273, and that gives you 308. And we write K. It's not degrees, it's just called 308 Kelvin. Then we have a second temperature that is 125 degrees Celsius, so the temperature went up, plus 273 equals 398 K. Again, you have to use K. You cannot use degrees Celsius. You'll never get the problem correct. And what are we trying to find? We're trying to find the second volume, and I think it says in liters, so we must have the unit of liters. Let's make a little space just for that. I love it. So the equation we're going to use is V1 T2 equals V2 T1. Ta-da! And again, we're trying to find V2. So I'm going to isolate V2. We'll go V1 T2 over T1. And now we'll plug and chug. I'm going to start way over here again. So V2 equals 5 liters, 5.00 L's, times 398 K, all divided by 308 K. Well, let's look at our units. I love to cancel units. The K cancels the K, and we end up with liters, and we do a little math, and we get 6.46 liters. Ta-da! That equals the second volume. And does that make sense? It looks like the volume increased, and that makes sense because the temperature increased. Let's erase, and let's move on to the next slide. And the next slide says end of notes for worksheet 1. So we'll end the podcast at this point, and I'm sure you're looking forward to the